Hello, everyone. I'm Guiltygyoza. This is Nonsense. We are from Topology. And we're making fully on-chain games. Strangely, it's becoming a category in itself recently. So that's a good thing. Shoshin is a fully on-chain game on StarkNet that we will be presenting today. And I think that there is a lot of technical talks in terms of which blockchain ecosystem offers the best TPS, the best decentralization, all these sort of infrastructure talk. We want to make this talk more design-oriented because we believe that the space needs new application paradigms, paradigms that can inspire us, things that do not make sense outside the blockchain, and things that are not just about hyper-financialization, bubbling things. So here we are. We're going to talk about Shoshin, which is a fully on-chain game about autonomous agents and composable engineering. Before we start, I want to talk about our beliefs at Topology. So we think that after DeFi and NFT, the world computer needs new paradigms to prove its worth to humanity. And there has been a movement surrounding the concept of autonomous world, which is primarily incubated in the EVM ecosystem. Now, we fully support the theoretical construct of autonomous world, but we think that this construct provides insufficient structure and guidance as to what exactly is to be desired. So we think that a digital world that is fully decentralized is not desirable in itself, unless the world enables new experiences that no AAA game studios or no corporate-driven metaverse schemes could ever deliver. So Topology's priority as a company is to help discover and invent the new paradigm. Today, we will talk about a little bit about Isaac and Mumu, which is our past experiments. Then we will move on to Shoshin, which is our current focus. So Isaac is this experiment we did around last summer where we ran numerical simulations for celestial bodies that revolve around each other. It's a game where players have to collaborate, all inhabiting the same planet, to dodge the suns, and there are 3 suns in this solar system, in order to thrive on the planet. So this experiment, although very fun for ourselves, has some issue. So this was August 2022. StarkNet testnet had some non-negligible TPS issues. Not that TPS is low, but more like it is unreliable and sort of a little bit unpredictable. So it percolates to player experience being not so nice. Moreover, we believe that the 3-body problem is a superb narrative, but the project was too big to be iterated on effectively. So we pivoted to find something smaller and more engaging and easier to iterate on, which gives us Mumu. So Mumu is this fully on-chain simulation that you can call it digital chemistry. So there's this concept of digital physics. Again, in the autonomous world theoretical construct, this is similar in a way, but we can better call it digital chemistry because it is about synthesizing objects into one another and deliver these objects from source to destination. So a little bit like synthesizing following the digital chemical formulas, if you will. And the entire simulation is run in Cairo VM. Visualized at the front end. And we have pretty good feedback from the players. As you can see, they are players putting a lot of effort into innovating on designs that can maximize the delivery, synthesis and delivery of targeted objects to the destination. So if you look at the leaderboard, the first entry delivered 39 fire, which is this element along the digital chemical formulas that the game asks player to deliver. So the top solution delivered 39, whereas the trailing solutions on a leaderboard deliver single-digit elements. So there is a difference in player putting effort to really innovate on these solutions. But we feel like Mumu is a game that is part of something bigger. If you will, it's a game within a game. It should be a game within a game. And so we moved on, looking for something that is more scalable, more intense, and more engaging, which gives us Shoshin. So Shoshin is a fighting game where players invent the mind to pilot the characters to play the game. So Shoshin in Japanese, right? Beginner's mind. This game is about inventing minds, designing the minds. Now the game loop is pretty simple. If you're coming from machine learning research, you'll realize this loop is basically what autonomous agents, machine learning agents do. So you have, in every single frame, you have the perceptibles from the environment, which the agent will sense and process with their mind to produce intent. Right? So perceptibles with the mind will produce intent. And the intent would drive the body, which results in physics, bodies relocating and changing its state in the environment. And then the body interacts with other bodies, because you're in a duel with the opponent fighter, through physics simulation. And this simulation will produce where everyone is, what everyone is doing for the next frame. And then there's this housekeeping task where we check HP level, stamina level, etc. And then you loop to the beginning for the next frame. Perceptibles, mind, intent, body, physics, and housekeeping. And this is entirely in the Cairo VM executed on StarkNet. A little bit into contract architecture for devs here. So transaction coming into our contract would enter from engine, which goes from top to bottom. So perceptibles are prepared for each frame. That goes into a library called BTO, or binary operator tree. So we're representing these mind as operator trees. If you play 0x Monaco, the racing game by Paradigm, they accept Solidity bytecode as race car strategies. We do not want to restrict Shoshin to programmers. So we're not making a game where you submit bytecodes to us. We want to give you abstractions which you can grasp and design the fighting strategy with it. And BTO is our sort of back-end representation for the strategy. These are abstract syntax trees, or binary operator trees, as we call it. After the trees, you have combo. So if you play fighting game, there's this input buffer mechanics where you can pre-queue the action into the input buffer before your animation finishes. Combo buffer is precisely that. And then you have the body. So the body contracts are, think of them as race cars. So you have different cars you can drive. They have different mechanics, different feel. These body contracts are the playable characters represented in Cairo smart contracts. And then lastly, you have physics. So the physics is a contract that simulates the 2D rigid body interactions between the characters. And then you have numerics, which is our implementation for fixed point arithmetics. And this is in Cairo 0. So as we just heard, Cairo 0 is going away pretty soon. We are rewriting everything in Cairo 1 as we speak. So now we have some early footages.
Yep. Hi, everyone. Here we have some footage of a fight between our two characters. On the left here, we have the Antok character fighting against, on the right, Jessica. And in this interaction, early in the fight, we can see that Jessica is able to dodge Antok's attacks by dodging. So this is one of the character interactions we have in the game, is Jessica can dodge attacks with her dash ability. Here we have another view of a fight between two Antok characters. we're going to see on the right here that Antok's going to perform a horizontal slash against the Antok on the left, but because of blocking, he's able to knock the character on the right. In this slide, we can see the character editing tools we have. So when you're designing a character's mind, the first thing you'll be making is conditions which inform the mind decision making. So this condition here is the opponent attacking condition that a user has made. And here we can see the logic for that, where we're seeing if the opponent is currently Jessica, and she's using her slash ability, her upswing, and then followed by the Antok attack abilities. In this slide, we can see that opponent attacking condition being used to inform a defense combo. So here is the overall mind state for the character, and we can see the opponent attacking condition informing the defense combo. So our current focus is to continue play testing from that demo we see. We want to make the mind editor as debuggable and accessible as possible for playtesting. We also want to add more pre-built conditions and minds that allow players to play the game without having to start from scratch. And then lastly, we want to add cinematic effects to give the game more of a wow factor. And that's something that I'm really looking forward to. So we look forward to getting early feedback on our character move set design, as well as other aspects of the game.
Okay, taking a step back and talking a little bit more on the technical side, given this is supposed to be a technical conference. The second focus of ours is to re-architect the entire contract in Kara 1.0. And what we really need is modularity. So modularity basically means that the mind can be represented in whatever ways the players want. The characters, the playable characters, can be represented in flexible ways, as long as it adheres to some kind of foundation rules. And we think it's interesting to think about what we're calling application-specific VM, because this game wants to be so modular and flexible that it almost becomes a platform in itself, a developer platform in itself. And so calling it just an engine doesn't really justify it. We think application VM with a defined application-specific ISA, or instruction set architecture, can allow us to deliver the kind of modularity that we want. The modularity where the mind is no longer represented only as BTOs, the operator trees that we talked about. It can be represented as anything as long as it adheres, it compiles to our Shoshin ISA. One example would be if you want to represent the mind in neural networks, you can if it compiles to our ISA. And there's the Giza project working on machine learning in Cairo, so we are looking forward to collaborating on that. Same for characters. So playable characters, as long as they compile in our ISA, can be played in this game. Same applies to map. Same also applies to rules of the game, as in starting HP, conditions of winning, etc., etc. And June, also our developer on the back, is in charge of re-architecting this and rewriting this in Kara 1.0. So we look forward to that. Now, our next focus comes down to scalability issues. So a little bit statistics for you. As we run the fight, 120 frames worth of fight fully in a Cairo VM with 2 average-looking agent behavior. This entire simulation takes about 750 steps in Cairo VM. And considering StarkNet having a step limitation to every transaction, we will very quickly run into that limitation. So you can imagine if I want to make an agent that is 10x the complexity, and I want to enter into a duel that is 1,000 frames, I will run into the limitation of the underlying blockchain. And this really is not to push the underlying blockchain to scale better just for our application. This also does not mean we can magically slap a layer 3 and say, happy ending. We think that we want the fight to be trustless, not necessarily fully on-chain. As long as it's fully trustless, as long as facts derived from the fights can be registered on-chain, that is a totally valid fight. And so we are thinking about state channels where if I enter into a duel with you, we establish a state channel in which we exchanges proofs of our decision-making on each of our agents' side, and we accomplish this fight in off-chain state channel, which produces a proof to be settled on-chain, whatever blockchain it is at the end. And this, we think, is the model that can help us scale Shoshin to much more interesting agent, much more complex fights, and so on and so forth. Of course, much more precise physics simulation and so on. But we deliberately postponed this because if Shoshin doesn't prove to be engaging, there's no point in scaling it. So we want to make sure that it's a mechanics that is engaging in the first place, which justifies the scaling effort. And this is just a sketch that we had a conversation with Ellie about sort of these multi-machines exchanging fight states and proving to each other about valid moves. And Ellie specifically advised against using MPC, so we'll stay away from MPC. Now, our final focus comes down to art. So there's a notion that says fully on-chain game is fully on-chain and everyone can build clients and games are fully decentralized and flexible. Not really if the game is not compelling to begin with. Like, ask yourself the last time you go to Steam or Epic Game Store and you are repelled by a game because the art doesn't look good to you. I think this space not only needs superior technology, it also needs aesthetics. And so this game also wants to thrive and excel in its art design. This is just very early sketch where we think about character design, their moveset, the narrative that will go behind our redesign of the characters. So this is Shoshin to you, and we have a QR code here for early playtesting. So if you scan this QR code, which we'll distribute later, you can join a waitlist, and we will contact you when Shoshin is ready for playtesting. And thank you, everyone. Yeah. Feel free to ask us any questions. Yes, sir.
Is there any kind of randomness in the fight, or is the outcome of the fight decided once both strategies are input in the engine?
Right now, the fights are deterministic based on the mined inputs. We are thinking of different game modes that will allow more interactivity, so that once the two mines are committed, players can make changes to the mines, make adjustments mid-fight or across multiple rounds.
Okay, thanks.
I think just to follow up on that, if we have randomness, then we need to have a matchmaking engine that pairs up with that randomness. With determinism, it's easy to matchmake and determine who's winning. But I think if machine learning researcher looks at this, they would demand randomness, obviously. So in a frame, my agent would want to maybe draw a random number from a distribution and act based on that random number, whatever that distribution is. So this is pretty cool, but this obviously would lead to a further blow up in our step consumption. So if we really want this, we probably need to pursue the state channel first, the client-side proving idea first.
Yeah, hi. I'm just curious about the Shoshin VM in general. Like, what's your what's behind the decision of you making it a VM, and what's constitute inside the Shoshin VM? And are you gonna like open source it so that yeah? Because I'm just not sure what's inside this VM, and like whether it can be used for other game or something as well.
Well, so there's this famous problem called Photoshop for AI, which I think GPT is helping to solve it right now. But this problem was first posted by a game developer in 2008, the game developer that helped made the Spore game, the procedural generation creature game. Photoshop for AI basically means, can we create a platform that allows users to create NPC AI very easily, just like using a Photoshop. You use Photoshop to create awesome graphics without understanding the graphics algorithm and stuff, because they abstract it away in filters and all that pre-built functions. The same problem applies to AI, but not sort of AGI problem, but more like game AI. And so there are many schools of approaches to represent AI. Right? So in game industry, you have hierarchical state machines and decision trees. You have many different ways to represent complex behavior. So it comes down to, does our contract enforce a particular representation? Or does our contract welcome different representation? But we can't just make a simple interface without posting a further restriction. Because then you can have unfair situation where maybe a GPT-powered agent fights another fully on-chain, minimal contract agent, and that's just not fair. And so we need to impose constraints. So it comes down to, how do we flexibly impose constraints to these sort of arbitrarily represented behaviors? And we think having a Turing-complete platform just for this application makes sense. Hence, we're calling it a VM in itself. Yeah, it will be fully open source, because the whole point of making this is so that it welcomes different kinds of representation. So you can have an agent in neural networks, as long as it compiles to our ISA, which should be open sourced. Yeah.
Thanks for the answers.
You mean showing the link? Oh, yeah. So the QR code is will lead you to a Google form, where we have a couple interesting questions for you, and after filling the form, we will consider you for early playtesting. Basically, you can join the waitlist. So if you're interested in having a peek into the pioneering experiments, fill out the form.
I think you mentioned app chain, especially for current Focus 3 and 4. I forgot if it's Focus 3 or Focus 4. But I'm working on research trying to identify whether or not the ultimate architecture within blockchain is a use case chain with multiple applications within the same use case going to happen, or it will be ultimately the ecosystem of app chain, which means the app chain will bring the consensus directly to a general use layer. So given, from my understanding, you mentioned that you need a unique virtual machine for your particular game or ecosystem or automated world. What's your view on the use case chain, or you ultimately position yourself could be a use case chain in the future?
Well, I think our colleague June, coming from the Cosmos ecosystem, have very strongly opinionated ideas in terms of how app chains should evolve. But I think ultimately this comes down to which application paradigm catches traction. And that defines everything else. That defines how the infrastructure should evolve towards. Otherwise, you would have a lot of empty, semi-empty infrastructure with different opinions, and no real user validating the opinion in the infrastructure. So I think that's why that's why I think one funny thing about us is that there's this idea where the most successful and meaningful projects in the ecosystems are those that make infrastructure, right? There's this fat protocol thin application thesis many years ago, which could be true years ago. Our opinion is that the space needs people that really do applications super seriously. And this may seem like a gamble in the eyes of investors, but this is our focus because we think driving from application can justify everything else in how we think about infrastructure and so on.
That's good. Yep. Thank you.